Welcome to Driven. I'm your host, Paul Perrone. We're going to learn and talk about AI, robotics, autonomous vehicles, and so much more. Check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. So kick back or buckle up and become driven. Well, Alexander, hey, it's good to catch back up with you here. We first met, what was it, at a TED Talk about over a year ago. You were doing a talk on Babylon. I guess we'll talk about that. Your one of your companies, and I was doing a talk about AI. And anyway, good to reconnect. It's been some time.
Yeah, it's great to be here.
Well, I know you've done a lot, and I guess if you wouldn't mind just kind of summarizing, introducing to the Driven podcast audience, kind of yourself and what you do.
Yeah. So, well, again, Paul, thank you for having me. So, my career started with a company called Babylon Microfarms. I started out of a dorm room at the University of Virginia, and so we now build modular vertical farming systems. So, for those that don't know, vertical farming is a method of growing plants indoors. You use hydroponics. So, the basically grows plants 2 to 3 times more quickly using 90% less water. So I was really taken aback by that from a sustainability point of view and the potential for kind of building, using technology to allow people to grow their own food. And so most of the industry are these massive scale, like commercial operations, and there's a big place for them in the world. But we focused on micro farms, which were kind of small modular units that we remotely manage. So it took a lot of R&D and a lot of it's a pretty steep learning curve coming out of college, but we essentially built kind of a next generation appliance that allows people to grow food at home. And we built some patented IoT technology there to basically remotely manage the farm. So we administer nutrients, we track what's in the farm, we actually adjust all the variables. So it's like a little automated greenhouse for businesses to grow their own food. And we grew that company. We built a factory in Richmond, Virginia. So we actually are the OEM for these machines based here in the US. And we operate over 350 locations across North America and in 5 countries. So it's been a crazy ride. I recently stepped aside that and joined the board. We have a great new CEO in there called Mark Oshima, who's kind of an industry guy. And I think the company has a long road ahead to get where it needs to be. But it's I kind of got it from 0 to 1, and we're now entering a next phase. And so yeah, that was a really incredible journey. Really proud of the work we've done there, and we're kind of the leader in our niche within the vertical farming industry. So very very proud of that. And as far as this conversation, I'm actually just starting a new company called Buckstop. So we are building an AI platform to appraise the value of electronic assets, anything from kind of robots through to renewables, even microfarms, and then coordinate collection at the end of life. So we're trying to basically streamline kind of the recovery and end of life process for business owners.
Wow. Well, yeah. So that's fantastic. I mean, I remember the Babylon thing. I want to dive in more about what you're doing with Buckstop, but just to kind of circle back to Babylon real quick. And you said you were at the University of Virginia, right? When you started this?
That's right.
Okay. So I went to grad school there in the 90s, I guess. You're much younger. So I would assume, just because you look younger. but so when were you at UVA, I guess?
Yeah, so graduated in 2017. So I
Okay.
born and raised in the UK, came over to study at UVA, and teamed up with my co-founder Graham Smith, who was in the kind of engineering school there, and started building prototypes in my 3rd year of college, and never looked back.
Wow. So where were you? Again, this might not appeal to people who don't know the Charlottesville or UVA area. So were you in like the dorm environments or an off-campus location when you started to grow these things?
Yes, we started out. There's an organization. It's now called Forge. It was called Hacksevo, which is kind of on that on the corner.
Oh,
For those
right.
who know. And it's like a kind of, I guess, like a hacker house of sorts. It does kind of, I think I put it like all of the cool stuff, useful stuff that school doesn't teach you. So they do a lot of coding, hackathons, just like practical stuff. So it was a really useful community that kind of helped us and gave us a little bit of space to just start kind of cobbling together our first prototypes. And that was where it all started.
I got it. So it wasn't like kind of growing plants indoors, which would raise the eyebrows of authorities, I
Actually,
guess.
it's funny you say that. That was a running joke because I did have like all of these prototypes and stuff in a dorm room basically, and yeah, a lot of people were like, "What are you growing in there?" I was like, "It's just lettuce."
Well, so what do you grow in these? Describe for me, like, what this what this structure is, and like how it works, and how big are they? I guess given I give a sense for how big these indoor growing systems are.
Yeah, so our flagship product, the Gallery, is similar size to a double door refrigerator. So these are kind of it's a self-contained kind of vertical greenhouse, and we offer about 45 varieties. We focus primarily on kind of high value, highly perishable items. So your culinary herbs, edible flowers, it's all edible food. But we also do a lot of like lettuces, kale, stuff like that. So your salad greens, microgreens, and culinary herbs is where we focus.
Got it. And so is there? So what's some of the constituent technology that makes growing indoors? I'm not a green thumb. This is going to be a great episode for my wife, who is like all into plants and everything you can imagine that's greenery. So I'm like on the inorganic side of the family. She's on the organic side of the family. So explain to me, who is really not to use a pun, green with respect to this kind of technology.
Yeah.
How does it work? Like, what do you have? Do you have like sunlight lamps, or what's the thing going on here?
Yeah, so it may be helpful to start where the industry was when we started, and I'd say it's still there to a large extent. But we were building these little hydroponic systems, and so to grow plants hydroponically or indoors, yeah, you need grow lights. You need to control the solution they're grown in. So you've got to have nutrients, got to have the right kind of pH ratio. There are a lot of variables that go into it, and so when we were building our early prototypes, it's like this little science experiment you have to do, and it's not super complicated, but it is cumbersome and it's a massive barrier to entry, right? So your average person or business in our case, like growing your own food is very appealing, but it's like, do you actually want to go through the learning curve and running this little science experiment? And so when we were doing our early prototypes, it was like, well, this seems to be the barrier to entry that we want to tackle because most people would love to have a source of fresh produce on site if they could, but they don't want to kind of go through this learning curve, and there's obviously a lot of risk to it. If you get it wrong, you kill your plants. It's a pretty bad experience. So we set out to basically develop. It's called Babylon IQ. So it's a remote, it's sort of an automated system to administer nutrients, pH, control the irrigation, lighting, and we basically develop growth recipes. So it's a programmable system that allows us to kind of control the environment for a given crop type. And so on the gallery today, the user basically receives pre-seeded pods, not dissimilar to like a Keurig cup, and then scans them into the farm, and then we take over and administer the recipe. So it really kind of elevated the user experience to something that is functional for someone with no green thumb. And that pops up in our sales pitches a lot, is that you don't need a green thumb to be successful with our micro farms. And so that's the kind of core of it. But yeah, so we have a sort of patented IoT system, and we've essentially miniaturized the kind of semi-automation that you would see in a commercial greenhouse. So we kind of designed this whole system using Raspberry Pi, or it's Arduino, and then we moved to Raspberry Pi, basically just to kind of control these systems in a way that's like low cost, miniaturized, and then fits nicely into our appliance.
Yeah. So what are the sensors that are used to kind of assess the health and the wellness of these systems?
Yeah, so we have a couple of the sort of core ones are like the electrical conductivity of the water, which allows you to derive kind of the nutrient concentration,
Mhm.
the pH, and then the temperature and humidity. Those are the kind of core ones. I'd say we have a lot more than that in the system now, primarily for redundancies. Both for that and then also for the user. It's like we're checking the flow rate of the water. We have cameras. We have a few other things in there that allow us to kind of make sure we're providing oversight to the system.
Gotcha. And so for controls, do you control like the brightness or the intensity of like the lamps and what have you?
So we did a lot of testing to select the right kind of wavelength and lights, but it's mainly kind of in terms of actuators, it's the irrigation, it's the ventilation of the farm, so making sure the air is flowing and you've got the right kind of airflow in the system. And then yeah, actually administering kind of pH and EC, so you kind of micro dose different pH and EC and nutrients depending on the plant stage of growth.
Gotcha, gotcha. And these nutrients you said, are these the things that come in like the Keurig like pods that you just give to folks, or is it like how do they get those?
Yeah, so the seed pods, so we use an inert growth media, so it's really just kind of a structure for the roots to grow
I
in and
see.
provide the seed something to like latch onto. But then we dose the nutrients in a liquid form, actually moving to a powdered form that basically makes sure the solution that then saturates that medium has everything the plant needs to grow successfully.
Well, that's super cool. And I think you said you had these on like cruise ships or something, right? Is that right?
Yeah, well, I think that's one of the things that is so exciting about what we do is that in theory anyone and anywhere could be turned into an indoor farm with our system. So our main business is in kind of colleges, universities, K-12, and healthcare. But we have some really cool clients at the moment. So yeah, we've just done I think our second or third cruise ship. It's the first vertical farm in the world on a cruise ship, which was a fun project. And then we've also got some like we did work with the U.S. Olympic team, so the athletes in the training village are growing their own food. We just did a project with the LA Clippers, so we're starting to get some really kind of fun use cases where they're benefiting from like ultra high quality ingredients on site. Obviously, there's a sustainability angle, but then in the cruise ship case, like what are they going to do? There's no way to have fresh produce if you're out at sea for weeks at a time, and so we provide them a solution that they can have kind of produce grown on demand right there on the ship.
That's cool. That's cool. Now, is this available to or going to be available to like the consumer at some point? Like, I mean, I could think of just people loving to have some sort of mini version of this, or even a larger version in their home or garage or wherever they might be able to fit it. You know.
Yeah, we're not ruling it out. I think we've got a lot of work to do in the kind of business space, and there's a plenty big enough market for us there. I think for where we're at as a young company, that's where we're focusing. But we have a product called the STEM Garden, which is like a smaller, more accessible unit where I think we do have a couple of like prosumers, we call them, who really want to get into it. But the systems we build actually grow too much produce for your average home, we found. So it's on our roadmap in the future, but at the moment we're not focused on consumer.
I see. Yeah, I know. I think I've remember when the Toys R Us used to exist, and I used to take my son there. There was always kind of like the quasi science section. It was like one aisle. Everything else was bikes and games and what have you. But there was like one aisle of like sciency stuff, and they would have like these little kits. I mean, there was the sea monkeys where you could grow these like living creatures. I don't know what the heck they even were. But then there was like these little mini hydroponic kits where you could probably grow a plant. Of course, there's the Chia Pet. Nothing like the advanced technology that you have, but like somewhere between that really super low end and what you have, there was that gap could potentially be closed for consumers, I would think.
Yeah, I think that's part of what we were looking at. It's like growing plants is a very like common and innately kind of human thing to do. Like people like doing that, right? Gardening is very popular, and historically people always grew their own food, right? So it's actually an anomaly in this time. Most people don't know where their food comes from, and food deserts and all of these things. So I think there's a lot of kind of tailwinds for us there of like trying to kind of help people to grow their own food. And I'd say another massive thing just related to the Toys R Us analogy is this whole STEM education piece. I think it is not just limited to kids and students, but we found that one of the most surprising like good things as we've installed these farms around the world is the behavioral habits. Like we saw in one senior living home that like produce consumption went up 35% once they installed the farms. And that's not just grown by us, but it was this whole thing. Suddenly the entire senior living community is involved in farming. Like they have this thing like in the dining room, and it's like an activity for the residents. They eat all the produce from it, and that actually drove up kind of produce consumption across the board, which is like an amazing data point for us, and really kind of part of the behavioral change we're trying to drive, particularly in schools. You see kids lining up for the salad bar. You have this kind of really visually engaging
Yeah.
farms. You often have the chef harvesting, making a salad in front of the kids, and it really changes the whole paradigm of like, instead of eat your vegetables, by in the cafeteria line, it becomes an engaging experience, and it can actually change the way people kind of view produce, which is a great thing.
Yeah, they take ownership and hey, eat these things that I made, kind of
Yeah,
philosophy. Interesting.
exactly.
So what in the robotic space, I've been in this automated vehicle robotic space for 20 over 20 years, and we've explored different markets. Agriculture was one of them at one point. We actually had a customer who had these machines. They're called nut harvesters. I'm sorry, but that's what they're called. And they these big machines that would go along, and these big nets would come out and sort of hug the tree and shake it, and then the nuts would fall into these nets. And they wanted us to kind of automate being able to kind of navigate along this copse of trees, and we had like lidar, and it would check the distance and then steer based on that, and it worked. But like what we found pretty quickly is the margins in the agriculture business are pretty tight. It's a commodity, and so there's not a lot of money. There wasn't a lot of money for you know automating some of the platforms that we were doing. And I'm just wondering, like, when did the light bulb go off for you, or that, hey, what you're doing here could actually have a return on investment for the company, kind of the entrepreneurial side? What was the key moment that made you think, hey, this could be a business?
Yeah, it's an interesting question. As I'd love to talk more about the sort of ag robotic space. I think there is a lot of potential there, and it's growing very quickly from what I can see. But for us, it was really about kind of enabling people to grow their own food. And I think when I saw this industry kind of growing as quickly as it has been, and really everyone's focused on sort of building the biggest farm in the world, it would seem sort of counterintuitive to me that indoor farming actually has a lot of self benefits, and that if you were able to bring it closer to the consumer rather than building a warehouse on the outside of town, what if you had small farms that could benefit from a little bit of economies of scale in production? You could put those into the kind of point of consumption, eliminate the supply chain altogether. That was like, just seemed to intuitively make sense to me. And it's not an either or thing, right? We are a complement to those big farms. We're all part of this sort of growing industry. But it was also just, as I was looking at, really no one was tackling it at the time, and a few other companies have come and gone in the space. But the kind of smaller scale on-site farming, in light of a lot of the corrections going on in the industry, which I can expand on if you want, but seems like a great alternative approach to this, where you're actually able to drive increase produce consumption. You're able to kind of eliminate that supply chain, increase access to certain ingredients, but then you also have this kind of beautiful like centerpiece, which for a lot of our clients, there's a lot of value in that. They can bring the farm into their community, and that's something that's like a radically new way of doing things for them.
Yeah,
So yeah, the ROI for them is both the produce, but also the experience that we deliver for them.
yeah. I mean, actually, the elimination of the shipping and transport costs, and also just the contribution to greenhouse gases associated with the fuel and what have you, and that is certainly an advantage in being able to grow something locally. Uh, yeah, I mean, obviously, there's some obvious economic benefits there. I just was wondering if the total cost, clearly at some point the total cost of doing this has to be cheaper or better than the alternatives, right, at some scale. And I guess that has happened within Babylon. Obviously, they're selling this technology to the right markets. I guess it's only a matter of time before, with scale, maybe that becomes more
Yeah.
possible for consumers too, I guess.
Yeah, so our kind of long-term play was to be, somewhat analogous to the solar panel industry, but for vertical farming. You can have these small modules that are mass-produced. You can daisy chain them together to create farms of different sizes. And because they're self-contained, they don't require kind of custom build-outs. You could kind of roll them in and reutilize some kind of urban spaces for urban farming. So that's still the plan. Our costs are coming down all the time. That's one of the reasons we built our own facility here in Richmond. And I think we still have to go to much higher volumes before the costs are down to the point where it's accessible to consumers. But with every step down in cost on the hardware side, more of the crops that we offer become economically viable. So right now, of that 45 varieties, some of them are just a premium product, right? You're growing it on site, it's fresher, it's much more nutrient dense. But for some, like your microgreens, certain culinary herbs, we can actually save people money on those. And so obviously for those reasons, a lot of our clients choose to lean into them. And the other thing to remember with produce, especially these kind of culinary herbs, microgreens, like they have a very short shelf life. It's actually super inefficient, and the spoilage rates are insanely high for stuff that's being shipped from the West Coast to the East Coast, et cetera. So for us, certainly the culinary community immediately get the benefit of growing it on site. You have that kind of flavor punch, and you don't lose any nutrients to the dehydration and other
Yeah.
degradation in supply chain.
Yeah, and you mentioned that they're in Richmond, Virginia, and I know there have been some awards like Virginia, what was it, Green Supplier of the Year. There was a Made in Virginia CBS feature, I think. Have you? I mean, have you gotten some pretty good national or possibly even international coverage? Or
Oh yeah, we've been very lucky, I think, because also the nature of what we do, it's very relatable, right? People see it and they immediately like, I want one in my house, and that's actually a great thing for us. So we were recognized by Time Magazine as one of the top green tech companies in
oh,
America.
awesome.
Actually this month we won the Food and Beverage at Sea Trailblazer of the Year award. So that cruise ship installation definitely got us a lot of attention.
Very cool. Very cool. Well, like I'm looking forward to seeing something like this in the home because I just again I know anything that's because once it's automated, I know that that will be sort of the aspect of this technology that ropes me into it because my wife will make me reboot the server or whatever's involved with with these things. Um, but yeah, no, it's fascinating. I'll show some pictures here for people and video as we can get them to overlay with the podcast so that people can see what you're describing. But yeah, it's just a fascinating business.
Well, thanks. Yeah, I think the pictures definitely help, and there's plenty of content out there on our website and stuff about how it works. And I think for me the broader theme is this sort of climate adaptation. We talk a lot about climate change. That's obviously a big, much needed challenge for humanity to tackle. But I think for me, it's like some of these solutions. It's like a lot of the damage is done, and it doesn't really matter who caused it. It's sort of we're moving in this direction where you have more fragile supply chains, you have risk of extreme weather, et cetera, which in agriculture is a huge issue, right? And we see this now. There kind of starts. I think last year there was the chilies that go into sriracha hot sauce. There was like a weather event, and they were out, so the price skyrocketed. You couldn't get sriracha. That's like one niche example, and that stuff's happening more and more. And so indoor farming broadly and what we do is a tool to counter that, right? You can have your own supply chain. It's resilient to the outdoor climate. And I think it's a good example of these practical solutions that can help people build their own, like solar can give you your own energy, micro farms can give you your own food. And that's just helping to create kind of a more resilient world that can, adapt to a changing climate. And I think that's partly for me, with this and the next company, that's really important. I think just building practical tools that can allow people to take control of their own, whether it's food, energy, or waste for my next company.
Awesome. And is there any generative AI technology that I mean, it's got so many applications. Have they begun or you begun to think about how that can sort of bring like help this what they're doing at Babylon?
Yeah, so for that one, we just launched our IV agent, and I think my co-founder Graham Smith has led that. But We're essentially building in kind of I guess an advanced chat bot to guide people through the growing process. It was actually interesting, and I wonder how maybe this is a common problem across different hardware devices. We have a knowledge base, we have all these training videos, and we looked into the data and saw that most operators were watching the same video every time. Like you'd think you do it once, how to cut the crop, how to change nutrients. There are sort of basic things a user has to do. And we went into the data and saw that people were watching these videos every time,
Hmm.
which maybe it still works, but it's not the best user experience. And so we're trying to design the agent to actually like kind of pop up at the various times and just tell people exactly what they need to do. So it's sort of a proactive tool to like abbreviate those videos and just be like, hey, like I notice you've got to do this. Like here's exactly what you need to do. And I think that's just one good example where that's going to ease the burden on our customer support team. It's going to deliver a better customer experience. And again, just kind of get into this more sort of proactive help mode. So that's one of the more practical use cases for us. I think beyond that, I hope humanoid robots and other things could dramatically change the use case for farms like ours. Like if you could remove the labor cost or reduce it significantly, I think that makes indoor farming broadly and specifically what we do much more viable.
Yeah, yeah, and I actually wonder if you connect the some of the sensor technology into the generative AI, if like that could then provide some automated sort of diagnostics and hey, here's something that you should be aware of, based
Oh
on.
yeah, so some of our core IP, we talk about remotely managing these farms. We joke internally that it's like air traffic control, but we essentially have like an internal dashboard where you can see these hundreds of farms around the world, and you can track all of the variables. So we can see temperature, humidity, sort of what they're growing, all of these different things, and we can manually adjust them if we want. But I remember in the early days when we had kind of 15 farms out, we would like basically going through a spreadsheet of sensor readings and manually kind of checking. And we'd had someone do that, which was just terrible job for someone to do, but much needed. And so over time, a lot of what we're doing is kind of automating those. We have automated test scripts. The farms kind of basically analyze their own data and run tests, and then if there are kind of any anomalies there, it alerts our support team, and they're able to kind of dig in on it. So I think those are kind of practical use cases of ML that we've implemented, and that's what's enabling us to kind of scale this fleet internationally.
Gotcha. Interesting. So does that relate in some way to your sort of your new venture? I know you're doing some stuff with AI, and again, can you sort of restate for those of us who kind of in some regards new to some of the things that you're doing, the applications of this technology, what this new deal is, and how it maybe ties into what you were doing.
Yeah, so with Babylon, while we were a vertical farming company, we were also the original equipment manufacturer, the OEM of essentially a smart appliance, and so we were deploying these devices all around the world. And I think I started to get really interested in kind of the life cycle management of devices, and being fortunate enough to meet folks like yourself who are deploying robots and whether it's robots, renewables, other kind of devices that are remotely managed, which is increasingly almost all of them. And so I saw some commonalities there where basically people have very similar problems, and then end of life for their devices, because all of them will become obsolete at some point. It's inevitable. That was a really underserved area, and the net result from the consumer's point of view, and we unfortunately had to do this at Babylon at times. Like once the warranty ends, like it's kind of your customer's problem. And I think that if the customer is left with whether it's a home appliance or some large installation, if they're left with that, so the device becomes obsolete.
So, what
I
are
think there's a really
some examples of devices here? So, devices like some examples, I guess.
Yeah, so electronic vehicle chargers
Okay.
would be a good example. So that would be a fleet that are being managed. We also look at kind of these robots. Ag robots would be an example. There's a company that's deploying those. The customer is using them. Some cases the customer owns them. Some cases the OEM does. But those are the kind of things that are really happening all around the world, where you have kind of software dependent hardware that's performing a function. In our case, it was growing food. In EV chargers case, you're recharging things. But in all of those cases, they're going to die at some point. And that at the end of life, the device is basically, in most cases, it goes in landfill. And that is a bad customer experience. It's bad for the environment. And more importantly, I think they're leaving money on the table in terms of the kind of critical minerals and resale potential for the components.
So some of those are kind of like I don't know, more commercial industrial devices as opposed to, again, a device could be, a home computer, it could be a coffee machine, it could be a washing machine. Is that, or do you not draw the distinction?
So we do, as in we look primarily at kind of industrial and renewables, robotics. That's
Okay.
where we're focused, but we're not ruling it out. And you see this Apple and other kind of big companies on the consumer electronics side have launched very successful trade-in programs, and that is creating a much better customer experience. It's enabling them to sell more phones, and then they're able to repurpose or recycle those older devices. So it is happening, and we're basically trying to build a framework at Buckstop that allows us to appraise the value of maybe non-traditional assets. Consumer IT is easy because it's very liquid and there's lots of reference points. But for an EV charger or other infrastructure, it has the same problem, but there is no aftermarket. So at Buckstop, we're designing kind of an AI-driven appraisal tool that can help us go to manufacturers, appraise what's out there, figure out when it's go obsolete, and then help them coordinate collection and process those devices at the end of life.
So yeah, walk me through. So that life cycle is, there's a company that has something like one or more EV chargers, as an example, and they have a relationship. They would have a relationship with your company, and there's an appraisal of its value, when they're about ready to get rid of it, or when they've, or ahead of time, like before they decide to get rid of it.
Yeah, so it can be both. I think the core of what we're doing is trying to understand finished goods in their raw material terms. So, while whether it's a home appliance or an EV charger, those are quite sort of devices that recyclers don't really understand. But at a raw material level, if you go a layer deeper, you can see what's in these things. And then those components and materials have liquid markets and people who can process them. So that's the core of what we're doing, is trying to reduce things to their raw materials, so we have a true terminal value in the event that it is obsolete. And then that's something that we can work with to help organize collection and find the right processor for it.
Gotcha. So you're not just looking at like, and I may use bad analogies. You're not just looking at like the battery. You're looking at maybe the lithium that's in the battery and somehow figuring out how to extract that.
That's exactly right. Yeah. So
Okay.
we're basically trying to build out the information layer, and batteries are actually a great example. It's a really high growth area. There's a lot of recycling infrastructure being built. It's very profitable to extract the lithium if you can find the feedstock. And so in our case, we'd be looking at, okay, what kind of devices have batteries? How many, like, can we aggregate those and then take that battery like feedstock to a lithium processor to extract it?
Or copper. I mean, copper is always a big deal, right?
Oh yeah.
In components. So okay, you do the appraisal. So how do you go from getting the thing to extracting these elements, which may be deeply embedded into this product?
So I'd say that is the challenge for recycling, and they talk a lot at the moment about kind of critical mineral recovery. Recycling is one of the only levers we can pull in the West to increase our kind of domestic critical mineral supply. And so it all starts with the data, and I think that's where we're focusing all of our efforts. Is like, how do you build a framework to understand what's in stuff, and if in the case your gold, your palladium, your other things that are in these things, it might be really like grams. Or I actually have a this is the motherboard from an EV charger that I dismantled on my balcony, that happens to be sitting on my desk. And as an example, we're going through looking at the components that are on there, and some of them will have high value, some of them will have very high like compositions of certain components. And so that's the kind of analysis we're doing. We don't plan to get into the processing. It's more about identifying the stuff and then aggregating it and then sending it to processors, because there are smelters and dedicated processes for your lithium magnets, other things, but their challenge is finding the feedstock and finding out where the stuff is. So that's really where we're focusing our efforts.
So you're doing this without necessarily, schematics or drawings of the component that you're analyzing. Because it's a third party black box product, right? They're not going to give you the design, I guess.
That is one of the challenges. I think what we've shown is, and again, the scrap industry exists today, right? Like when someone leaves their TV or their fridge on the street and it disappears, that is the scrap industry. Like there's it's a sort of little bit of a gray market, and there are some kind of enterprise players, and there are ways to kind of broad stroke estimate what stuff's worth, between the copper cable and motherboard. These things are traded, but we're trying to go deeper, and we're proving that actually using AI, you can do these appraisals very quickly and at scale, which is really exciting. And of course, if the manufacturer wants to give us more detailed information, we can get to 100% accuracy, but you don't need to be at 100% to just be like, okay, is it worth collecting? Is it worth someone going and, for example, extracting the motherboard to see if it's worth sending? Because in some cases, you'll have recyclers that specialize in the copper, or they'll specialize in the motherboards. And so extracting components and selling them is one of the things we're looking at and trying to figure out how to do that effectively.
Gotcha. And so, how does AI, I guess, help this process then? What is it that you train it with, and what is it telling you, I guess?
Yeah, so there's sort of two pieces to it. One is if you look at appraisals today and then kind of circular life cycle assessments, if you're familiar with those, so like there are consultants out there that will do kind of chemical assays on a product to understand what it's made of, and that would help a manufacturer. I think Apple actually just announced some really amazing studies on their products for Earth Day earlier this week, where, for example, they say this is what our products are made out of, this is the proportion of recycled material we're using, and so they're kind of building that circularity narrative. So that stuff can be done, but it's a consulting project on a per device basis, very cumbersome and expensive. The same goes for appraisals. If you have some deployed assets and you're trying to liquidate them, in a lot of cases, you're getting a third party appraiser in. They're trying to kind of look at the market, and these are both pretty like clunky, expensive processes right now. And so that's really what we're trying to get to with AI. Is like, how do you automate the appraisal process, looking at the sort of true residual value in raw materials and then the resale value, and that gives us an idea of what the device is worth in a kind of resale or scrap scenario. And then doing these device level assessments to get to that terminal value of raw materials. So we think that the two things there can be done very efficiently with AI. And importantly, it also allows you to move from this kind of one-off device by device project to something that's like a repeatable framework that, for us, we want to categorize every electronic device on the planet eventually. That's where we're heading.
Gotcha. So if you had a component like, I don't know, I'm just thinking in my terms, like some GPS system, I don't know, would that be a recyclable component, like an old outdated GPS unit, or no?
We think really anything with a plug
Okay.
should be recycled.
Okay.
So yes. And actually, I'll tell you. So I went to Ghana earlier this year to a place called Agbogbloshi, which is supposedly the most polluted place on earth, and it's kind of ground zero for the urban mining industry. And I think urban mining is probably generous. It's sort of a electronic waste dump. But it was fascinating to see it's sort of the last stop for electronics. So in the US and the West, your data centers, your consumer IT, there's a robust domestic infrastructure to process those. But for a lot of stuff, like you mentioned, your kettle, your like kind of other good, and these things are the plug. It's not economically viable to do it domestically. So it ends up in places like Agbogbloshi, where basically people get a hammer out and just have at it, because the copper, grams at a time, the small wires in there, the small motherboard, they all do have value if you can aggregate them. And it was fascinating to see, as it's an environmental catastrophe. Conditions are terrible, but the people there are actually very happy because they're making money. It's a high paying job for the region, and I think that's a signal. One is like, we need to obviously try and do that better and make sure that people are recycling things in a more environmentally friendly way. But I think it's also a signal that there is value in all this stuff. It's just a question of like, can you identify it? And these guys with no technology have figured it out, and
Right.
that it's a profitable business for them. So we're just looking at that and trying to see like, how do you identify what is economically viable to process and what's not.
Gotcha. Gotcha. So like if you dig into one of these devices and you think it's got, I don't know, a lithium powered so and so or a copper based whatever, and then you discover after opening it it has whatever, silver, I don't know, just regular metal based instead of copper based something, right? Um, that's only discovered after it's cracked open, I guess, right? Unless you have the manufacturer's information. Is that right?
So it's interesting. A little bit of both. Like I think in this case, I was manually pulling apart an EV charger to check what we'd found with the AI, and we found it to be pretty accurate. The big part of it's like actually beneath the hood of these finished goods, a lot of the components are the same, right? You've got your motherboards, you've got your memory, you've got copper wiring. So there are ways to basically back into an estimate that's fairly accurate without getting the manufacturer's info. But I can say obviously with my previous life, Babylon, our product had over 1,000 components, 320 unique components in the system. And from our bill of materials there, like you can, if you have manufacturer's input, you can kind of track back to the spec sheets for a given component, and then you're going to be able to get the kind of mass and the material composition. That's not economically, it's not time feasible for us to do that at the moment, but there is a future state where manufacturers lean into this, and then if we're able to have access to that, we can give them 100% accurate kind
Yeah.
of algorithmic assays of what their product's made of and what components have value in recycling.
And sometimes their manuals and certainly their repair manuals, if they're available, will give you, insight into information. I've been amazed with generative AI just with some of the oddball devices that we work with in the autonomous vehicle space, asking some specific question about it, and it seems to know some pretty good information about it that was probably in the manual somewhere, but it was buried on page like 95, and and it's not always right, of course, yet, but it's getting better. But it's yeah, it is amazing what you can probably infer from just manuals and and repair guides that are online. So like, what does the training set look like for this system?
Yeah, so a lot of it is those public facing information. So, we're looking through manual spec sheets, some other sources. There's a fair amount of infinite inference and like confidence scoring. We're pretty early with this, but I think we've proven that it's feasible on like one device category. That the data engineering challenge ahead of us now is trying to look at how we scale that up, in just kind of an economically feasible way.
Awesome, awesome. Yeah, I can see that. And then the the picking apart process, like the who does that? Is that something that your company would do, or is that outsourced to somebody who's going to then take extract these raw materials from it, or are you planning some automation there too? Like
Yeah, so
Wally, did you see the movie Wally? I assume.
that comes up all the time. I
I
need to.
guess so. Yeah.
Yes, so the processing part's interesting because for us that's part of our kind of back end that we're figuring out. It's like really what's the most economically feasible way to process stuff, because there is a world where you send it to international processors who will handle a much broader range of stuff and potentially lower value stuff. And then domestically, there are very established companies that kind of shred and sort, and they have various kind of levels of automation to do that. And the goal is really just to refine these electronics down into their raw materials and make that sure the purity of those materials is sufficient to be smelted back down into material. There's also a resale path, which is actually the most environmentally friendly and potentially the highest margin if the devices work and you can find a market. So that's a lot of what we're doing now, is trying to sort through what are the vendor networks and processor networks that we will need. And there are some amazing companies, one called Mobius Industries and one called AMP Sortation. AMP is like a very sophisticated, like fully automated, like shredding, sorting facility. They do, as I understand it, primarily like municipal solid waste and like plastics today. But e-waste is something that's interesting. So there are companies out there that are really pushing the envelope of like what's possible on the automation front, and that the result there is you bring down the processing cost per pound. And if you're able to do that, then more stuff is economically feasible to recycle. So um, we're looking at partnering with people primarily, but not ruling out getting into processing ourselves down the line. But as with all these things, it's like we can see where we want to be in the long run, but right now it's just figuring out where to start. And we think that this kind of data for valuation and collection is really the pain point we want to tackle first.
Yeah, I mean, I love these conversations because I am, I usually, I can talk a lot about robotics and some of these things, but like I'm very ignorant of food. I know nothing about food except how to eat it, and so I'm fascinated by learning those topics. But then this, like, I never really understood how recycling worked. I know when we lived up in Northern Virginia, we had to separate the plastics from the uh, aluminum from the paper into different bins. And then we came down here to Central Virginia. We're out just outside Charlottesville. There was a single stream facility. And I'm like, this is great. We're just throwing all this stuff into one thing. I don't know how single stream works and how they extract this stuff out. Is there a similar method for like extracting the parts that you would need from this device, like that these companies use, or is it much more complicated than that? I may be oversimplifying because I'm very ignorant of how it all works.
Yeah, I think it's a real challenge, and I think for consumers, I think people are relatively aware that a lot of what's recycled, or a lot of what goes in the recycling bin doesn't actually get recycled, and there are just challenges with kind of sorting and a lot of spoilage in there. But for electronics, as I'd say, there are companies out there that are much further along in the processing side, but it's a complicated process because again, you look at a motherboard, you've got all these different things in there, and this shredding it down, isolating like copper. If the copper is coated in the cabling, the sheath around it, that means it's not a high enough grade to be smelted, as an example. So it needs to be stripped of the like plastics and thing that surround it. So yeah, it's a very like nuanced challenge in that sense, and I think that's really part of what we're trying to do with this data collection effort is to identify like how this how different components and materials relate to each other in between devices, and we think that can really help with the sorting process. Just as an example, like the vision systems on some of these sorting robots, if they are able to identify the product and that's paired up with a data set that says, oh, that type of product has you know these components, the sorting system may be able to actually go in and identify them and pull them out, put them in the right bucket, and that helps makes things more efficient. Whereas I think right now the issue you have on the automation side is like even though the underlying materials may be similar, you've got very different shapes and sizes of devices, different conditions, and that kind of goes back to the example in Ghana I mentioned. But these people are manually doing it, like they know. So I'd like to think that can be automated over time, but yeah, it's definitely a complicated problem, and there are so many steps in the process. And also the other big thing is like actually stripping it down to its raw materials is a pretty low, it's a high volume, like low margin solution. Like if you can extract components and reuse them, or if you can actually repair the device and resell them, that is better for the environment and higher margin. But it doesn't mean that eventually every device, everyone listening to a podcast who's deploying automated devices, everything's going to die at some point. It's kind of just the way things go. And so trying to create kind of a waste to value solution for electronics, and hopefully build a framework that can apply to all of these different devices that are coming online and scaling at the moment. Hopefully, it's going to help us recapture a lot of these materials.
Yeah, and there might certainly, beyond what humans are able to do, there must be sensors. I mean, not just cameras, but spectral analyzers, metal things that can detect metals, and I mean, you have cocaine sniffing dogs. I mean, there must be some way to detect certain elements. I would think with some of the sensor technology. Are there? I guess that's a question. Or are you aware of any of those, or that could be brought to bear here?
Yeah, as I that's a very good question. There definitely are, and I think the vision, it starts with the vision systems, and then also it starts with this kind of analysis. Because, like, as an example, on your memory cards, the teeth of your memory card, if someone can visualize those that have gold on them, that's like historically, where so people will literally pull the teeth off a memory card, and that is a separate recyclable material because it has a high gold content. So, and it gets to looking at what components are in the device, what raw materials, and then in some cases, like the component within the component that has a very specific like concentration of a certain element.
Yeah, yeah, interesting, interesting. Um, well, that's fascinating. I guess yeah, and then of course the picking apart thing, the automation of that would require manipulator arms and things that have some precision there that currently can be a little expensive, but obviously the price will come down for ar- manipulator arms and things like that over time, I guess.
Yeah, I think that's one of the things for us. We're early. We have a saying internally that sort of strong opinions weakly held. So what we're doing may change, but I believe that as far as the big picture, like electronic waste, it's already the fastest growing waste stream on Earth. I think we're at the beginning of that. Like there is a cliff of devices coming online, offline even, that will all need to be recycled. So the problem's growing, and I think the other part of this, just related to what you just said, like the automation is going to be a huge part of making this industry kind of flourish. And I think that's also enough stuff going on there. I think there are converging factors here that are going to really change the economic picture for recycling. And also, if you just think about it from an environmental point of view, it's kind of crazy that we're just like digging up like the earth to get some of these materials out there. And yet, when there are already pre-refined materials in the stuff surrounding us, most of that stuff, it's 78% of electronics go into landfill today
Yeah.
in the U.S.,
And
which is crazy.
and I guess you said anything that can be plugged in. Now, typically, a lot of things that could be plugged in, there's a chip, there's memory, and I guess that will beg the question of like, like privacy and data security at some point. Like, there must be, they must have to deal with this in the human capacity. They've got iPhones or whatever, even chargers that might have um, someone's Bluetooth connected cell phone contacts in it. I don't know. Some of this stuff might be stored in these systems. How do they weed that out now, or do they not? Do they?
Yeah, it's really interesting. So the kind of incumbent industry today is called IT asset disposition, or ITAD, and as we understand it, that this is kind of like enterprise IT management. So they are doing recycling, they're doing a lot of repurposing. So, like for example, a financial institution, they're going to upgrade their IT equipment every 2 or 3 years. What happens to those monitors and PCs, servers, etc.? So these ITAD companies exist to cater to that market. It's huge, big business. There are a few public companies out there, and it's very well established. But most of their revenue comes from data erasure and security. So they're doing kind of collections. They're sorting hard drives manually. They are cleaning them, in some cases shredding them. And that's the primary business. And there have been enough data breaches recently that it's a serious problem. I think the problem is going to continue to grow. That's because there's more and more IT hardware out there. But at the consumer level, it's a real challenge. That's actually come up in some of our discovery calls that your, I guess, non-traditional smart devices like your Apple Watch, your like Fitbit. There are things out there that have like an incredible amount of personal data on them that are probably going in landfill right now. And to recycle them, they're probably going to have to be new types of IT asset disposition companies that crop up just to cater to some of those devices. Even your like smart fridge, smart kettle probably has quite a lot of personal data on there that you wouldn't want getting out.
Yeah, yeah. Well, actually, it might be an area where the newer technologies that you're bringing to the table could further differentiate, because you'll know more about the devices, and maybe know more about which ones could have sensitive data on them, and then just hack the hard drive to pieces and collect the atoms.
Well, that's a lot of what's happening, and I think that's always a path, right? It's like how quickly can you just shred this stuff down
Yeah.
into its raw materials and get it back out there. That's one way of doing it.
Yeah. Yeah. Interesting. Well, I guess so. And now, is this? Tell me a little bit about the your. If you we're both based in Virginia, um, and I take it you're still in Virginia. I'm assuming you. Okay.
I'm in Richmond, Virginia right
Okay.
now.
Well, I'm just an hour and a half away, and when I first moved down here from Northern Virginia, where I was, and I was, again, I started this company 20 years ago. I was very naive about venture capital, and I just figured I knew how to build things. I knew about technology. I didn't know enough about venture capital, and then I discovered along the way, and the importance of it. And we have Intel Capital as an investor, and some other groups. Um, and But raising money in Virginia is very hard. Raising money outside of the Valley used to be very hard, and then there's Austin and Denver and what have you. What's been your experience with raising venture capital in Virginia, and what do you think could sort of increase the footprint of venture capital here in our region?
Ooh, it's a loaded question. And,
Just lay
well,
it all out there. Be blunt.
well, for us, it was interesting as you look what Babylon does today is so different to what we were trying to do. As in conceptually similar, vision still the same, but like what the product actually ended up looking like, the market, all the stuff we figured out. Like I don't blame anyone for not investing in our early rounds because it was just like we had like these wooden prototypes. They were just so not representative of what we ended up doing. But I think we made it happen. I think in Charlottesville we did Cav Angel, Charlottesville Angel Network. There are a lot of groups there, and you kind of just go around and make it happen. And then we were lucky between VIPS, Virginia VIPSI, I think they're called now. So the state group, they led one of our rounds. We've received SBIR grants, and we've gone on to raise pretty sizable amount of capital locally, and some from the UK, some from the Bay Area. You just have to cast the net pretty wide and hustle. I you see these things on social media like, oh, I spoke to 50 investors before I got my first term sheet. I was like, I think we spoke to 400 or 500. Like our numbers were just higher. And I think you just have to have kind of a very like high agency and high momentum strategy to it, or like that's how we got it done.
Yeah.
And eventually you'll get there. And that's not for everyone. It can be pretty demoralizing at times, but I also think it just depends on what we do. As in, Paul, you're in the hardware and robotics, and obviously the self-driving is a massive thing. The opportunity there is fairly obvious. I think for microfarms it's less obvious, right? It's a pretty like left field idea, and I think hardware is not for everyone. Although I'd like to think that's going to change in this environment now, both with kind of hopefully a renaissance in domestic manufacturing, and also just the need to move from, what do they say, from bits to atoms. I think that's actually a really exciting time to be in hardware, and AI and a lot of things are going to help drive the cost of launching those products down, which is very exciting. And anyway, so with that in mind, I think it's about having a compelling product, compelling market, and just hustling to make it happen wherever you're based.
Yeah. Yeah. Well, I think that ratio is about right. Like, 50 investors might be the right number in the Valley, but 10x that in Virginia might be what you have to do. Because
Yeah.
there's just certainly, it's a more risk averse environment. I found, and the Valley is used to that. Like your wooden boxes might be endearing. I mean, the first Apple was in a wooden case, right? So, and look how well they did. So I think this, whatever it is, there is certainly a cultural thing. There's just less, you know, large companies that have sort of made it big with venture capital here on the East Coast than elsewhere. But yeah, you have to hustle, and you have to hustle about 10 times more than West Coasters, I think.
Yeah, it's interesting. So we're going through Lighthouse Labs in Richmond for the second time actually, and it's a fantastic program affiliated with Startup Virginia, and I think that like they do amazing work. I think they've got most of the startups in Richmond are somehow affiliated with them. But there's definitely talk. There have been a few good exits, but no like unicorn exits, and obviously that can change the entire ecosystem
Yeah.
and kind of populate the next generation of funds and do all these things. Which, I think it will happen. And Virginia is so well placed between being the data center capital, logistically, like there's so much going for it. I think it's just a matter of time. But I will say for the new company, we got on the hamster wheel of raising money, and this may be a. I think the nature of what we're doing at Babylon was like we had to raise money because it's hardware and developing it's just is inherently expensive. Um, but I think once you're on that hamster wheel, it is very hard to get off, and not necessarily to get off, but to basically your funding to grow the business, and that there's a lot of downsides to that, particularly in the hardware world where things take longer,
Mm-hmm.
stuff happens, it's very iterative, and you don't necessarily know which iteration is going to be one that hits. And certainly for this new business, we're trying to self fund for as long as possible, go slow, and avoid um, the VC kind of approach for as long as we can. I think we will almost certainly need to raise, and but we want to make sure we've got our ducks in a row. And I think there are a lot of things around discovery, pain points, things that money doesn't solve. It's really just a time thing. You got to speak to a lot of people. You got to be very structured in your research, and hopefully develop, put the pieces together in a way that solves the problem. Hopefully in a scalable and exciting way. And I think you can do a lot of that without raising money. So we're trying that this time around.
Yeah, yeah. No, that's a good point. And I guess any thoughts on have you looked at or any thoughts on crowdfunding, like the We Funders and the start engines of the world?
It's funny you mentioned that. I looked at it for Babylon when we were looking at consumer at the beginning. I should have mentioned that earlier. And we went down a rabbit hole of Kickstarter. And it's very interesting on product launches specifically. It can be very successful, but there are some um, sort of thresholds around pricing and timing where, like, if you're a sort of sub $200-300 device or product, and the person does really kind of organize their launches, they get a certain number of pre-orders that they may have sold manually to place orders. There's kind of tactics that definitely drive success, and I think the same goes for crowdfunding. I'm very intrigued by it. I've seen some companies that went on to be big venture-backed successes do it as a way of community building. Like if you basically kind of make it your launch and it's like a marketing campaign of which the ask is to invest, I think it can be a really powerful like community building tool. So we're looking at it. I would say it's not the immediate priority for us with this business, but I think it has so much merit, and I hope there's more of it, because it's ultimately like if you can get your potential customers and your community to rally around you, I think it's a really strong foundation. And I think there's still a little bit of a maybe hesitation about it from institutional investors. It was like, oh, if you had to crowdfund, did that mean you couldn't raise money anywhere else? And I don't know if there's some truth to that historically, but I'd like to think that the attitudes are changing, and maybe the crowdfunding can become a important part of that kind of early journey for any new company.
Yeah, yeah. I mean, things changed about, I think it was 3 or 4 years ago when they really upped the limits. There was like two levels of it, and they upped the maximum limits that you could raise under these regulation CF and regulation A, I think it is. And I think
Mm-hmm.
they went from like 1 million to 5 million, like cap of what you could raise, and then I think regulation A allows you to raise up to like 40 or 70 million now, right? So if you do what's called, I think, a regulation A crowdfunding round, it can be substantial enough, right? To it's beyond an A round in some cases.
What
Yeah,
Yeah, one thing we looked into on that, I think, is just kind of your cost of capital. So, with your traditional angel or like VC, early stage VC round, right? You've got dilution. There are some legal costs associated with it, but it's fairly cut and dry. Maybe there's an interest rate if it's convertible. No, with crowdfunding, it's interesting because there's like a marketing element to it, right? It's like really like launching and advertising for the really successful ones. Um, your cost of capital goes through the roof. And I think that's why maybe it has a bit of a bad rep. Is if you're suddenly spending 20 to 30% of the money you raised on marketing it, that becomes quite an expensive way to get
yeah,
capital in the door.
yeah. Yeah, no, it's true. And, you know, you have a lot, then you have a lot of people on your cap table, and that, as you say, may make it more difficult for, institutional funders to come along later because they see this cap table with, you know, in their mind, a lot of potential investors slash plaintiffs. Um, and it's interesting. Interesting. It's an interesting area. I was just curious what you thought about that, and also for our region, I do hope, think of ways, and have worked with some local groups just to see how we can, um, make Virginia a more venture capital friendly arena. It's hard. There's a lot of components that are involved with it, um, but also personnel, right? I think this is anywhere, finding the right people, right? And there are technology personnel rich areas in the world, in the United States and elsewhere, and some areas have less, right? So what would have been your experiences being a Virginia based company? Um, are you prone to kind of bringing people in from different areas, or is there a pool of people here that make it,
Yeah, it's interesting. I think so. We ended up building the factory here in Richmond, and I think, to my knowledge, we may still be the only kind of climate tech manufacturer in the area, which actually was great. I think it had certain advantages because we're kind of the only, like, of course, there are other much bigger manufacturers in the area, but none doing kind of climate stuff. So that, from a hiring point of view, we've actually been quite fortunate there. We have definitely brought people in and incentivized them to move. But it hasn't been a huge lift. But we're kind of like an in-office manufacturing company, which, obviously, through this, we've had COVID. We've had, actually, we kind of set up the factory at the sort of tail end of COVID. But there have been some trials there, but it hasn't been a huge issue for us. And I think, again, we've been lucky with the nature of what we do. Vertical farming was quite a kind of attractive space. There's a lot of kind of young talent trying to get into it, and we were one of the only games in town, which definitely helped.
interesting? Interesting. Um, I guess so. Given that you kind of, in what you deal with is, you're affected by the supply chain, as like, what's your take on some of the issues that you're experiencing, and where you see things going with supply chain volatility, and the like,
Ooh, wow. Loaded question again, because I think that the few answers I can say, you know, at arm's length with Babylon, right? As a domestic manufacturer, there are some real challenges with it. We still import a fair amount of components, and the risks are very real. And that's a real pain for our team to mitigate, especially when we spent so long building out the supply chain to do things domestically. There are still components we're relying on internationally. So that's a challenge I imagine every manufacturer in the United States is facing right now. That is not easy. But I hope cooler heads will prevail, and that will not be as bad as people think it is going to be right now. But we'll see. With Buckstop, it's, ultimately, we are, recycling is one of the biggest. It's pretty much the only lever we can pull for renationalizing domestic supply chains for critical minerals. So the idea that we're going to be measuring what's out there and helping facilitate collections and originations could be a huge beneficiary from uncertainty broadly and the current trade war. So, we're definitely seeing that. Like, the current administration is making a big push for critical mineral sovereignty. There are definitely initiatives and funding being created for that, which, I think, in the scope of, they're cutting pretty much everything else. It's despite that, this is one area they're focusing on. So we're excited about that, and I think, regardless of the geopolitical stuff, ultimately recycling seems to make a lot of sense, and hopefully that's going to help keep more material here, create more feedstock and raw materials for domestic manufacturers, which will be great for everyone. But as these things will take time.
yeah. And I mean, as startups are able to sort of turn challenges into opportunities more easily than, you know, larger incumbents and companies, right? So I would, on the flip side, there's always there's the challenge, but then there's the potential benefit of there's presumably some demand that you would see here for increased manufacturing, at least in the U.S., and then therefore for your product. The cost of if the supply chain costs go up, then doing things locally, not only for Babylon in terms of its more locally grown capabilities, it becomes a strategic advantage, but also for what you're doing, um, extracting raw materials, closer to home could you could see significant demand for that.
Oh yeah, well I hope so. And it's still crazy. They in the scrap industry, the U.S. is Saudi Arabia. That's what they say. They call the U.S. the Saudi Arabia of scrap because people come from all around the world to collect the waste that's produced here and ship it internationally so that they can extract the raw material. So that industry is very well established and exists today. And so I see that as a big opportunity to move some or all of that to domestic processing so we can keep the raw materials and use them to kind of fuel the factories and kind of reindustrialization that I think everyone's hoping is going to happen.
That's brilliant. Yeah, I mean, we are. I mean, the United States is a big consumer of a lot of things, and so therefore there are a lot of things over here where yeah. I mean, it's interesting. You really onto something with respect to being able to tap into the raw materials that are needed from just the products that are in the hands of American businesses and consumers right now.
Yeah.
That's I think yeah, that's a great
Yeah,
opportunity for you.
time will tell, but no, we're very excited about it. I think the need is there from a people, planet, and hopefully economics are looking pretty good as well. So also for any of your listeners who are building robotic systems, automation, like this affects you. If you're deploying something with electronic hardware, I guarantee you it's going to die. It's just a question of when, and then what are you going to do with it? And in most cases today, businesses don't have a plan. They hoard it, they put it in the trash. And I would also add that in most cases it's illegal to put this stuff in the trash, but people do anyway. So there are kind of landfill bans, hazardous substance restrictions, other things like that that we're trying to kind of shed some light on, and again just help build a little information layer so people can know what their stuff's worth and hopefully get some money for it.
Yeah, yeah. 3D printing is and is a has been around, but there was a group called Local Motors. This guy Jay Rogers had this idea for localized manufacturing using 3D printing, but bigger things like cars and I was involved with Local Motors with they had this Ollie shuttle that they was largely 3D printed or 3D printed to some extent, and now Jay has like a furniture printing business called Hattie, I think, where they're printing chairs and stuff. It's really cool.
Mm.
What is your thought on that as that grows, as 3D printing grows, and how that might affect? And is there any advantage in if 3D printing grows as an industry in micro manufacturing, recycling those materials and things like that, could become important. It's not quite got the value of lithium and maybe copper today, but if that takes off, or do you see that taking off? Is that an area of growth for you all, or is it just way out there?
That's so interesting you mentioned it. I hadn't thought about it in the context of 3D printing, but upcycling is a sort of big term in circularity, and more like in places like Agbobushi in Ghana, a lot of what they're doing, they're extracting copper and stuff as raw materials, but they'll find ways to use a lot of these components, and they're super creative. There's some practical ones I've seen, like rubber and plastics get shredded down, melted into tiles, and those you see them on playgrounds, but people use them in their homes. Those are very low cost, like building materials. There's actually a company in Virginia called Trex that someone told me the other day that they do MDF wood composites, but they are essentially mining urban forests of finding wood and paper that they can collect, shred it down, and then build like composite wood that's reused again. So I think that that stuff happens a lot, and there are great businesses bought out of it, that built out of it. So to think about that happening in 3D printing, if you're taking plastic, you're taking some of these other things, melting them down into spools that could then be 3D printed into new products. That makes all the sense in the world to me.
Yeah, I mean, you could be creating these spools from the recycled materials. There's a company that I just found out about too down in Virginia, maybe near Danville, that apparently 3D prints like metal at a whole different scale. They 3D printed like a hull for like a ship on the Navy, and I'm like, my
Oh,
God,
it's
what's it?
I saw that. Well, that's 3D printing. Like, and have you seen like Icon, some of these building companies, like they're 3D printing homes. Like that
Yeah,
is, I think, that's like a silent revolution that is on the cusp. And the same with like humanoid robots. I think so much of this stuff is there. Like the technology exists, it's proven, and there's going to be a moment, and it might be all of this disruption. Maybe it's now. We'll see, but where this stuff just tips into the mainstream, and I'm very excited about the future for that because it's like 3D printing homes. I think they're 3D printing like nice, really good looking big family homes for like under $100,000. And it's like
it's a
that
it's
is
amazing. It's
that's a
amazing,
needle.
and that's sort of that local again that sort of localization because it not only just helps reduce cost and reduce waste, but it can be done everywhere in the world, right? Where somebody, of course, we could do it here in America anywhere, but somebody else in another world in another country where they don't have the manufacturing capability or whatever, it might be easier to 3D print something and then extract the raw materials from some things that they have. In this case, you could be this sort of the materials supplier for these 3D printer factories, right? For whatever materials they're printing.
Yeah, I love that, and I think we haven't used. I don't think we've used the term so far, but like the circular economy, that's what it is, right? And I think for us, we're focusing on electronics, but there are a lot of components and materials nested underneath that. But it's like how do you move from? I think they call it make use make waste. There's some catchy phrase that's used around, but essentially throwing stuff away when you're done with it is like a really like an anomaly historically, and it's part of this kind of high consumption, high waste culture that we've lived in, and to move to a world where things are circular. I've heard the term like usage cycles brought around, so like people really just trying to like reframe the nature of a product as like not like it's finished, it's going to go in the trash. It's like there is a plan for end of life, and then you're going to move it into a new phase of life, and that could be in upcycling, it could be kind of shredding it down like that. I think that's inevitable. Like it makes sense to utilize our waste and repurpose it in all of its different permutations, and that hopefully is a big part of the circular economy moving forward.
Yeah, yeah, it's amazing. So what's your take on if you look out 10, 20 years from now, what does the world look like with respect to uh, sort of reuse of materials and construction and manufacturing, not just in America but across the globe.
Oh wow, that's a big question.
Yeah.
Well, I can tell you with if Buckstop's successful, we will have basically measured and developed an end of life plan for every electronic product on Earth. So as we talk about usage cycles, that's sort of what we're trying to create. Is a world where every product, if it's got a plug, there's a plan for it at end of life, and you can very effortlessly basically liquidate that asset and hopefully recoup some money for it. So that's what we're building. I'd say that could happen very quickly from where we are today. I think all the pieces are in place. We're just trying to scale up the data collection part. Obviously, there's challenges on processing, collection, and other things that we need to scale up, but that is hopefully going to enable a circular so enable the circular economy for electronics specifically. And I have no doubt there are companies popping up trying to do the same. And from waste to value, I've seen like people are mining landfills for methane now to get the value out of it. I know construction waste is one of the biggest sources of scrap materials. So I think this stuff is already happening. I would say the Europe is generally like quite a bit further ahead from regulatory driven, but I'm sure it's going to come here. And a lot of this stuff is both just it's common sense, it's better for the environment, and if it's done right, it can be economically viable.
Yeah, and I've seen with some with other sort of attempts to sort of with societal issues like sustainability and other environmental needs, companies trying to form to address them in some way, but some companies in the past they haven't found the economic model that makes it a viable business, right? They rely heavily on subsidies, government subsidies, or what have you, and then eventually those go away, and then some of those companies go away. But like it's interesting because it sounds like you have with this a definite economic providing a clear economic advantage for something that also provides a societal and environmental benefit,
We hope
which is
so.
interesting. Yeah.
Yeah, we're trying to. As in, there are definitely challenges with the collection costs and other things. So you need to batch stuff in high enough volumes that it makes sense. But we're working through all that. And as I say, I think the economics, the incentives are aligned there. That hopefully we can really drive up collection rates. And I think I mentioned earlier on that it's only 22% of electronics are recycled today. So we're not really trying to compete with the existing recyclers. We're trying to go and capture the rest of that pie because it's crazy that some of this stuff is getting thrown in landfill and people are leaving on money on the table that causing pollution in the process. And hopefully we can kind of change that paradigm. Yeah, while I've got you here, what's next? What's going on with Perrone Robotics and what's next for you guys?
Well, we've been very busy with, we have a general purpose robotics operating system that has been sort of hyper focused on revenue driven transit technologies for automating those kinds of vehicles. We've gotten a lot of interest in ADAS technology for buses and vans. So ADAS, advanced driver assistance systems. So um, things that you might have on a car that are not on these legacy bus and van platforms, so that we can bring that technology to bear in these vehicles like right now, like so that pedestrian collisions don't happen with buses and other types of horrible accidents. And so that's been a driving demand, but and we're kind of honing in this transit sort of division within the company that's really taken off. And then concurrent with that, we have a couple of other verticals that are starting to really accelerate and allows us to take our general purpose robotics software platform, but also the kit that goes with it, and apply it to other vertical markets. Um, so yeah, we're focusing our energies on a few. We've been focused in the transit space, and that's kind of on its own path now. And now we have some other markets that we're pursuing. So, but like you say, there's challenges. It's always about execution. It's the circus of machines and people that we deal with. Every startup company deals with every day. It's a fun circus. You have to enjoy it, but there's all kinds of moving parts with people and machines and different personalities and uh, and I love it. I would never do anything else. But yeah, we're growing our our automation market footprint in different capacities as we speak. So
That's very exciting. I'm glad to hear it.
thank you. Yeah, and I've been leading the effort internally to bring some of the generative AI to our platform. So that's been a lot of fun. I think that's what I spoke to at my TED talk where we met over a year ago. And so that's been interesting and just a whole new world. It's definitely a game changer for every industry and all of our lives, and it's been fun to be part of it.
Awesome.
Yeah. Well, Alexander, thanks so much. Where can people find out more about what you're doing and about you in particular?
Yes. So I'm on LinkedIn and X. So both of those, look me up and post. Well, we'll be posting a lot more about Buckstop. We're kind of in stealth right now, but give me a few months and we'll be live and definitely sharing a lot about that one as well.
Okay, and there's a website for Buckstop at least, so you can. It's a
Yes.
placeholder.
Buckstop.com is a very plain placeholder right now, but again, give us a few months and we'll have some stuff
It's
for
a
you.
great domain name. Congratulations. They're
Thank
hard to get.
you. Yeah.
Well, thank you so much, Alexander. It was great talking to you. And yeah, I look forward to catching back up here and finding out more
Thank you.
about what's going on in Buckstop and your life. So thank you
I look forward to it, Paul. Yeah, if you're ever in Richmond, hit me up and thanks so much for having me on.
for sure. I hope you enjoyed the show Driven with me, Paul Perrone, your host. Don't forget to check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. Thank you for listening in. See you soon.